Hey everyone, welcome to another session of CeerazzleDazzle Physics. In today's session, we're going to be talking about changing momentum and using the formula F is equal to m delta V over t. So put down today's title, it's going to be changing momentum and using the formula F is equal to m delta V over t. And before we get started, guys, make sure you've watched my other videos before watching this one. Otherwise, it won't make sense, guys. You have to follow the order of the scheme of work. Right, so watch the momentum video first, then watch the principle of conservation of momentum afterwards, and finally watch this video from there, because otherwise it just won't make sense. All right, let's get started with the following scenario. Okay, let's look at the following scenario. So here we have cars A and B. Car A is traveling with some momentum and it comes to a stop later on. So it's traveling, it's moving, and it comes to a stop later on. Car B is also traveling and it also comes to a stop further on as well. So as you can see, car A has had momentum and then it's gone down to zero. Car B has momentum and that's also gone down to zero. It looks all identical right now. It is actually identical right now. But let's add the following twist. Let's say that car A changes the momentum. This happens in 100 seconds. So it takes 100 seconds for this to occur. So imagine that, 100 seconds. Yeah, count it in your head. But car B, this one takes all of this to happen 2 seconds. So imagine it happens in 2 seconds. So car A is changing momentum in 100 seconds. Car B is changing momentum in 2 seconds. Right? That's the start. Let's say you are standing on the bus of A and B. So you are standing on there. Right, the question is the following. Which scenario will you experience the greatest force acting upon you? In which scenario will you experience the greatest force acting upon you? Which is it? And to visualize it, imagine you're on the bus and the bus brakes. What happens to the force acting on you compared to if the bus slowly brakes? So which one is it? Which scenario do you think you will experience the greatest amount of force acting on you? Alright, so hopefully you have an idea that the second scenario over here, this one over here, you are changing momentum at the fastest rate because you do all of that in 2 seconds. So therefore you experience a greater force. What this means is that there's a relationship between force and changing momentum. There's a relationship between force and changing momentum. And that is what we're going to look at today, guys. It's going to be force and the relationship with the change in momentum. Okay, so there's a formula that can help connect this through, guys. It's going to be the following. Here we go. So here is the formula. Force is equal to the mass of the object times by the change in velocity divided by time taken. Or F is equal to delta P divided by T, where this is going to be the change in momentum over time. So let's label it, guys. Yeah, so here we go. Force is measured in newtons, mass is measured in kilograms, change in velocity is meters per second, time in seconds. Okay, easy stuff here. And obviously momentum is kilogram meters per second on the opposite side. So obviously if you should be comfortable using both of those formulas, guys. Comfortable using both of those formulas. I'm going to prove how we got those formulas right now. You're not required to know this, but it's nice for you to know. If not, you just skip forward to the next part of the video. Okay, right, so here is the proof of F is equal to delta P over T. Right, so we know that Newton's second law states that the resultant force upon an object is equal to the mass times by the acceleration. But we also know that acceleration is equal to the change in velocity divided by the time taken over here. Let's plug that in now. Let's substitute that instead of A over here. So now F is equal to m delta V divided by T over here. There we go. And look, we've done the first formula. Easy stuff. There we go. That's the formula over there. Because obviously I can extend that line using algebra at the bottom over here. There we go. That's that bit done. Also, if you don't like that, mass times by change in velocity, you can expand that outwards. That's the same as F is equal to mass. Well, the change in velocity, if you've forgotten, that will be equal to the final velocity V minus the initial velocity U. You can plug that in there. So therefore, it's going to be V minus U, there we go, divided by T. Happy days. Now, multiplying outside the bracket, this therefore becomes F is equal to mv minus mu divided by the time taken. And therefore, the mass times by v, that's going to be the final momentum. Yes, this will be the final momentum minus the initial momentum divided by time taken. There we go, divided by time taken. Final momentum minus initial momentum, that's going to be simply equal to the change in momentum divided by time taken over here. So then altogether, we've now proved that F is equal to delta P divided by T. Easy stuff here. Wonderful. All right, so let's get back into it. Let's look at a question using that formula. Let's start. All right, so before we move on, I forgot to mention this, but these formulas will be given to you in the exam, so you're not required to know them. So these formulas will be given to you in the exam. Obviously, it's nice to be familiar with them, but you're not required to know this. All right, let's test our understanding with the following question. Okay, so let's test our understanding with the following question. A 90-kilogram driver with no seatbelt crashes at 12.5 meters per second. Yeah, impacting against the steering column at 0.04 seconds. What is the force on the driver? What is the force upon the driver? First of all, good practice. Highlight the bits. What have you been given? 90 kilogram. This is the mass over here. 12.5. This is going to be, obviously, it's going to be moving at this speed, then it crashes. So this will be the initial velocity over here, u. That will be the initial velocity. Yeah, and 0.04, this one's going to be the time over here. Right, last of all, if you know that it crashes, surely you know that it crashes, it's not going to be moving at the end because it's crashed. So the final velocity. So this means that the final velocity equals to 0. Well, clearly, I should just use this formula over here. It's easy for me to use over here. So let's use this one over here. So therefore, we know that the force, we can work that out. So let's put it down. Force is equal to, number one, the mass. It's going to be 90 kilogram. There we go. That's the mass over there. Now the change in velocity is obviously going to be, we're going from 12.5 to 0. So the change obviously is going to be 12.5 meters per second minus 0. That's going to be my change in velocity divided by the time taken, 0.04 over here. There we go. Put it into a calculator. Let's do this. So I'm getting, everyone, force is equal to 28125 newtons, everyone. Easy stuff here, yeah? I know some of you might be thinking, can it be negative? Because obviously I might do final minus initial. So some of you might get a negative value, but that just tells you the direction. So obviously a force can be negative as well, because that's the direction. But make sure you're familiar on how to use this equation. F is equal to mass times by the change in velocity divided by the time taken. Easy stuff here. Alright, so the next bit of this topic is going to be talking about impact, time, and force. And we're going to be using the equation F is equal to delta P divided by T to help us in this. So the key thing is this. Always visualize it in real life. Cars have loads of safety features. Most of those safety features obviously require something to happen in regards to the time, the impact time here. Think about an airbag. So let's say an airbag, let's say a car crashes, yes? The airbag inflates, and the reason why it inflates is because it increases the impact time. So an airbag will increase the impact time. So let's put that down. So airbags increase the impact time. So airbags increase the impact time. But what implication does this have for the force? Well, look at the formula. If the impact time goes up, if this quantity goes up in mathematics, and the rate of change of momentum remains the same, you're still changing, this remains constant, so this value remains constant. So airbag increases the impact time. Therefore, what's going to happen to the value of F? What will happen to the value of F? So delta, let's say change in momentum remains constant, and you're increasing the time of the impact. What's going to happen to F? Well, F, logically, you'll get delta P is being divided by a greater number. F will go down to compensate. So, to summarize, airbags increase the impact time, and therefore the force experienced decreases. Last of all, for the same change in momentum, guys, for the same change in momentum. And that also applies for a seatbelt, guys. The time of the impact is increased, therefore the force decreases for the same change in momentum, guys. Easy stuff. Okay, so we're going to have a quick recap right from the top before we go, because we're done for another session. It's going to be the following. Number one, today's title was going to be the change in momentum, F is equal to m delta V divided by T. Second of all, rate of change of momentum. So we have two cars right now. We said that they are traveling and they come to a stop. One does it in 100 seconds, one does it in 2 seconds. In which scenario is there the greatest rate of change of momentum? Which scenario? And in which scenario would you therefore experience the greatest force if you were standing on there? We decided that the second scenario you'd experience the greatest force. Why? It's done in a shorter time. So therefore we said there's a relationship between time and force here and the change of momentum. We have the following formula. F is equal to m delta V divided by T. Or if you want, F is equal to delta P divided by T here. And then scrolling down, we then prove the equation for you. Some of you might have skipped that, but here's the proof for you. And last of all, we did one question, guys, in which we worked out F using the data in the question to test our understanding. And last of all, I then said how to explain it in words. Well, especially in like a collision and the car safety procedures. In a collision, the airbag will inflate to increase the time of the collision. The reason why is because the force therefore will decrease for the same change in momentum, guys. So the force that you experience will decrease. And that's the reason why we have these wonderful features like airbags. And that's it for another session of CeerazzleDazzlePhysics. Make sure you like and subscribe to keep my channel going. Obviously, the more that I do, hopefully I can help as many kids as possible, guys. So think about it, guys. And obviously related to real life, think about when you're on a bus and the bus breaks. Why is it that you experience that great amount of force when it breaks suddenly, yeah? It's all about the rate of change of momentum. Yep, and we're done. Ciao, ciao, and goodbye.